Thanks for dropping in. Well, it's become a winter tradition. Every December, I add a new critter to my collection of snow people, penguins, and seals. This year's edition is a bear cub. Like my other articulated creatures, this model uses a series of ball joints to make a range of adorable poses. But this isn't just a reskin of my older designs. I took the opportunity to make several improvements to the mechanism, and the best way to demonstrate that is to make another copy. We'll need to print a head, a chest, a bottom, and a plug. All of these parts were printed without supports, but your results may vary, especially when it comes to the chest. This piece was printed upside down, and the arms create some impressive overhangs. If that sounds too risky, a little support material might be a worthwhile trade-off for that one part. You might notice that the head and bottom are multicolor prints, with the eyes, nose, and toe beans already printed in place. If you don't have a multicolor printer, these parts can be printed separately and glued in. Or you can print everything together as a single color and paint the smaller bits. As a final printing tip, I use my slicer's fuzzy skin settings to create a rough surface on the outer walls of the head, chest, and bottom. This gives the final results a nice hairy look. It makes the ball joints more grippy. If you try this on your own prints, I recommend keeping the fuzzy skin setting extremely subtle. 1/10 of a millimeter is more than enough to sell the look. We'll also need some sort of elastic band to hold the bear cub together. For this, you can use a rubber band, a scrap of TPU, round sewing elastic, or a new option. This is a 3D printed TPU zip tie, and it's what I'm going to use for this demonstration. But really, the process is basically the same if you choose to use one of the alternative options. First, we need to push the zip tie around a small hook inside the polar bear's head. I've printed a dozen of these bears so far, and the tie usually slides in perfectly fine, but sometimes it gets stuck on a random bump. If that happens, try guiding it through with a bit of wire or another flexible guiding tool. Next, we'll slide on the chest and then the bottom. Now we just need to secure the tie. This works as you'd expect. Slide the pointed end of the tie into the hole and pull it tight. You might need some pliers for this part. The hole in the tie is intentionally undersized, so it should hold its position automatically. If you use a rubber band or other alternative, pull the band as tight as you can and secure it with a knot. Finally, we'll trim off any slack in the band and close the whole thing up with a plug. Keeping with tradition, the bear cub has an alternate head with a hat port. This is the same size port I use with the snow people, penguins, and seals, so you should be able to reuse hats created for any of those designs. If you're looking for nice hats, check out the remix section of the Flexible Snowman Fidget on Printables. There you'll find wool caps, Santa hats, sun hats, and much more. That's it for this year's Flexible Critter. I've already received a few requests for animals for future years, but don't let that stop you from making your own suggestions. I will run out of animals eventually. Okay, until next time, happy printing, and thanks for stopping by. Thanks for sticking around till the end. Since you did, here's a bonus model I published recently that didn't get its own video. This is my latest educational model, the Law of Sines Ambiguous Case Teaching Triangle. You may recall when learning trigonometry that an SSA triangle, that's a triangle with two known sides and a known angle that isn't between those two sides, may have two possible lengths for the remaining unknown side. This 3D print demonstrates that wordy ambiguous case physically. By swinging one of the triangle's arms, we can create two different triangles that hold true to the dimensions we were given. This print includes some defined values, but the model is available with no labels at all, or, if you prefer, teachers can use the Fusion file I've uploaded to create their own triangles with custom dimensions. As long as you enter valid values for the sides and angle, Fusion will create a triangle for you that properly positions locks to snap the moving arm in place. My thanks go to Pete Langshaw for suggesting the idea. If you're a teacher looking for a similar educational model, or know a teacher who could benefit from a creation like this, please leave your suggestions. More educational models like this are in the works, and I plan to release one every month.